Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to the Reliability Matters podcast. I'm so glad you're with me today. This is episode number 96. As I said in our previous episode, we're getting very close, only 4 more episodes to number 100. For our 100th episode, we're going to do something that we've never done before. Our 100th episode will be live. It will be broadcast live on LinkedIn and YouTube on July 26th at 10 o'clock a.m. Pacific Daylight Time. We'll replay clips from several of our prior episodes and hear a few comments from some of our past guests. As we creep ever so close to episode 100, I want to thank my guests and you, our listeners and viewers of this podcast. Without all of you, I would just be a talking head. And Lord knows we have enough talking heads these days. If you're watching this on YouTube, click on the subscribe button and click the bell icon to be notified when new episodes are released, including our 100th episode. If you want to watch our 100th episode on LinkedIn, just follow me on LinkedIn. If you're watching this on YouTube, the link to my LinkedIn profile is right down below. Just click the Show More button. If you're listening to this podcast on your podcast app, just click on the show notes for my LinkedIn information. A couple of episodes ago, I talked to Dr. and Professor Ron Lasky about a couple of books that he wrote. We also talked about a book he didn't write. That book is entitled Troubleshooting Electronic Assembly, Wisdom from the Board Talk Crypt by industry gurus Phil Zarrow and Jim Hall, available on Amazon. Both, by the way, were prior guests on this show. Well, today we'll have a conversation with Phil and Jim about their book. If you've been in the electronics industry for more than a few seconds, there's little doubt that you've at least heard of, if not met, Phil Zarrow and Jim Hall. Phil has been involved with the PCB fabrication and assembly industry for more than 35 years. Phil is the president and principal consultant of ITM Consulting. His partner in crime, Jim Hall, has been involved in the electronic assembly industry for the past 26 years. He's a principal consultant and resident Lean Six Sigma Master Black Belt with ITM Consulting. He's also an instructor in the Lean Six Sigma programs offered at Dartmouth College. Together with Dr. Ron Lasky, Phil and Jim designed the SMTA's SMT Process Certification course. Phil and Jim also host the popular audio series Board Talk, which is available through Circuit Insight. Here's my conversation with Phil and Jim. Well, welcome. Welcome to Reliability Matters, or I should say, welcome back to Reliability Matters. I'm glad you guys are with me today.
Hello, Mike. It's good to be with you.
Good to be here, Mike. Thanks for having us.
Of course. Well, thanks for agreeing or being voluntold or being arm twisted or whatever the case may be. So this happened, right? This happened. This is 272 pages of the unique, the wisdom and the unique humor of Phil and Jim, the Assembly Brothers. Before we get into your book, what's going on? The last time we were on this, you were on the show. You guys were pretty locked down. The world was pretty locked down, and as troubleshooters and consultants that have a history of going into facilities and investigating and finding out what the problem is and what the solution is, that's really difficult to do when you're locked down. Training is difficult to do. Or challenging anyway, when you're locked down. How did you guys get through that? I assume things are back open again and you're, getting on airplanes and doing all that. But tell me what that experience was like for you guys.
Well, initially, when the COVID hit and everything closed down, we were afraid, business is going to flatline now. As it turned out, there were some instances, particularly related to healthcare equipment related to COVID, where there's no substitute for being on site. We, basically put on the mask, got on the planes, walked through the very empty airports, and were on site. But a lot of the other stuff, of course, we did remotely. as much as possible. And yeah, we made it through. We're still kicking and thriving. And Mike, if you recall, interestingly enough, I think one of my last gigs right before as COVID was kicking in the state of California was closing down. You and I was out in Orange County, and you and I were going to get together for dinner. And you called me back and said, Phil, every place is closing down. There's nothing nothing available for dining. So we wound up in a parking lot at having In-N-Out burgers in the in your SUV
in the front seat of my car. Right. I remember that.
Couldn't beat the ambiance. Yeah, very cool.
Yeah, service was a little bad, but the food was good, right?
yeah, great conversation. Yeah,
right, exactly. Yeah, I remember that. I was calling around, to find a restaurant that was open, and that was a couple days after California officially shut down. So there was a few restaurants that quite didn't get the memo yet, but I couldn't get into those. So yeah, that was an interesting meeting, and that was kind of the precursor of the next crazy 2 years, right? I mean, that was just a small preview of things to come. Jim, did you guys do virtual courses before COVID hit? And were you able to just, turn back on the virtual machine, or what was that experience like?
Yes, we've done virtual courses online for some time, but I have to say that was very restricted during the at least the first year of COVID, and then it opened up a little more. But now, fortunately, trade shows like SMTA and Apex are operating in the not virtually, and so we've been able to go to those and do live workshops again. But it was significantly teaching in general was definitely restricted during the higher, more intense times of the COVID lockdowns.
Right. So you, in addition to your daily activities at ITM, where you guys are consultants and troubleshooters and trainers and all of that, you've got a few side hustles going on, all kind of related to ITM. And one of them is you produce an audio series. I would call it a podcast. Traditionally speaking, it's not really a podcast, but it's very similar to that because it's not on podcast apps. It's on one particular website, circuitinsight.com. But it's a show you've been doing probably well before podcasts were around, called Board Talk. And it kind of mimics or plays homage to the NPR Car Talk radio show, where two semi-nutty guys, mechanics in that case, with very peculiar and odd sense of humor, provide a call-in format where people call in and say their car is making a strange sound, and then they try and diagnose what that means and all of that. Your show is very similar to that in terms of style, which is a real standout in this industry. I can count on half a hand how many people in this industry that are teachers, that are speakers, professional speakers, that are both informative and entertaining. They usually get one or the other. You guys are able to get away with both. So tell me about the Board Talk show. How did that start, and how long has it been going on? And just give me a little bit of a background on that show.
Well, first off, I'd like to give the ultimate credit to Phil, my brother Phil. Phil, for the long time, Phil has a great sense of humor and looks at our industry and says, we're a wonderful high-tech industry, but we take ourselves way too seriously. And our whole industry would be a lot better off if we could laugh more, in particular if we could laugh at ourselves more. And that being his basic philosophy, he looked at Car Talk, saw what they were doing, and said, let's do it for our industry.
Oh, very good. So this was Phil. We can blame Phil or thank Phil, depending upon what you think of the show.
Thank Phil.
Jim and I, first of all, have known each other for, I think, close to maybe exceeding 40 years. Lost count a long time ago. And we were both, big fans of Car Talk. And when I first moved to New England from California, one of the first things Jim took me to was to Cambridge, and
Our fair city.
our fair city, or their fair city. And we're in Harvard Square, and he points to a building.
No, Phil, come on. You're at Harvard Square.
Harvard Square.
Harvard
and
Square.
He points to this building. It was near the yard, and there was not a lot of garbage.
There you
He
go.
points to this building, and on the third floor window, it said Dewey, Cheatham, and Howe. And this was Mecca as far as we were concerned. This is where the brothers' office was. Of course, their broadcasting was a studio in a little bit further away. And then Jim also took me down the road to the Good News Garage, which is the garage they're always referring to that the brothers owned. And it was built in the 20s or 30s. You could just see some guy in the background look like Krusty the Mechanic, and you're waiting for a car to fall off the lift any minute, exactly as they depicted it. And then many years later, I was very fortunate in that NPR was having a fundraiser, and they said for this much donation you get a recording of our bumper music. Well, I had that already. They said for X amount of money you would have lunch with the Car Talk guys. I go, oh, you got to be kidding me. So I figured, well, ITM could definitely afford a donation to NPR, and so ultimately they went down there. It was like a Wednesday afternoon, and we met at the studios where they were recording this. And there was like 75 people showed up, a number of people from the Midwest, Southeast, and of course, major from New England. And they split us up in a group of 25 each, and they took us on a tour. At one point in time, we turned this corner, and all of a sudden, there they were. It's a little glass studio, donut in one hand, coffee in the other, cackling over some lady who's transaxle on her Saab and falling out or something. And I was just totally mesmerized. I mean, here are the people I actually, I've never been really cared about any celebrities, but these guys. So then we ultimately they continued the tour, dragging me along. A little bit later, they take us out to this banquet room. We're sitting around. I'm sitting at this table, and a few other people. Guy from MIT, which is their old alma mater. A couple other people, and all of a sudden, lady announces that the brothers are coming in. They just finished their show, so they came in. And with their entourage that you usually heard about, those of you who remember Car Talk. And I thought they were going to stand up front and answer questions. They go, "No, we just did it. We just did a broadcast. We got to eat." And they go grab some food. Next thing I know, empty chair. Tom sits down on one side, Ray on the other. And it just can't get any better than this. And so I had major conversation with Ray, who, by the way, worked in our industry many years ago between other stints. So definitely an empathy for us. And
a brother from another mother. Phil.
Basically. So I talked at the time. We had something we were starting to do called Board Talk, and at the time it existed as a session at SMTA, and basically for paying a fee that would go to the scholarship fund, come in and we would have some soapbox or rant, or, whatever topical information, and people could ask us questions. This is more like Stump the Chumps, but that was a start. From there, our publisher, Jeff Ferry, who published Circuit Insight, basically said, there's got to be a way of making this broadcastable. So it was, he figured it out, and that's basically evolved into the podcast that we do now. Fast forward 10 years, and all of a sudden I realized we've been doing these for 10 years. We had over 200 episodes. And the interesting thing about it was the information wasn't stale, because a lot of times Jeff will recirculate old episodes, and I try to listen for clues where and when we recorded it, and it was still pertinent information. And I go, wow. So either we give really timely information, or we're really vague, or something in between. So
or you're terrible at providing answers, so people keep having the same questions, right?
Yeah,
I mean, come on. No, you guys are great at answers.
Yeah.
So it's been over a decade now of Board Talk, over 200 episodes, as you just mentioned. That's a lot of questions. I've listened to many of your responses. They're easy to listen to because they're usually 2 or 3 minutes long. They're usually, it's not a commitment. You don't have to clear your schedule to do that. And they've always been very topical. And you're right, there is a little bit of consistency in the types of questions. And that's an interesting thing in our industry. We tend to kind of suffer from Groundhog Day. on this show, there was a season where we talked about voiding, and the more we talked about it, it just kept coming up. And there's all sorts of subjects, I think, that just don't go away. They won't die. We don't solve them. I don't know what it is, information block or whatever,
Well,
but
Mike,
yeah,
I think that part of it, maybe a substantial part, is the demographics of the technical people in our industry. Many people like Phil and myself got started in the early 80s when surface mount was taking off and electronic manufacturing was growing very quickly. And we're still around, many of us, although many of us are, our age are retiring. And unfortunately, in the interim, in the 80s and 90s, particularly the 90s and into the turn of the century, the industry, a lot of offshoring was going on. We didn't attract a lot of new technical process engineer type troubleshooters to the industry. The old guys like us hung on. And now we're seeing a gap in information as electronics grows in this country, in the US in particular, but around the world in general. There isn't a lot of that expertise. And older processes like wave soldering, we are continually amazed at the number of questions we get about wave soldering. But at one point, Phil and I said, that's because it doesn't go away. And most of the people who developed it, optimized it, and evolved it are gone. So the young people have to run these wave soldering processes. And where do they get information? So they send questions to us.
Yeah, that was actually, thanks for providing that segue. That was a few questions down my list, but let's go there now. We've talked on this show before and other venues of the silver tsunami, the retiring of experience.
You always had a worry with words, Mike.
Those aren't my words. Those words were given to me by, I think Phil Stoughton said those words to me. But anyway, someone did, and someone probably said them to him. But the retiring, the gentrification of our industry and this void that's created, because it's not one-to-one. One person doesn't walk out the door as one person walks in the door. 10 people walk out the door before one person walks in the door, and that's created this void. So we have two issues. Number one, we have the wise sages, and I'll say, the Dave Hillmans, Doug Pauls type people of the world that are subject matter experts for their company worldwide. They're, eventually one of them has already left. One of them is has been threatening for the last decade to go. But when they go, so does a lot of the secret recipe information, and they're not being replaced, at least not that I can see. Perhaps they are, but not generally replaced with one more super sage person, right? Maybe they're passing their information on to a team of people, but they're definitely taking away some valuable information with them that probably not one person knows, where all the process skeletons are buried. Mm-hmm. And that's one problem. The other problem is the industry will now rely on consultants, good, vendors, maybe good, maybe not good. If you ask me a question, it doesn't matter what the question is, the answer is always cleaning, right? The answer is always cleaning. Well, yeah, see the Maslow's theory, right? If all you have is a hammer, everything's a bed of nails. Everything to me is clean or dirty. But that creates a little bit of a potential conflict of interest to answer some of those technical questions, because they're going to the people who have a horse in the race, right? And then the other issue is the people coming in, graduating college with their electrical engineering, mechanical engineering, chemical engineering, technician, trade school, whatever education they're bringing to the table, they're coming in pretty green. And colleges teach electronic theory. They know they can read, the color bands on a resistor, but they may not know how much squeegee pressure to set the stencil printer to, or they may not know how to use an oven profiler, or how to adjust the foam flux head on an old wave solder machine, an old Hollis wave solder machine, or the oil intermix of that particular brand of machine. Things that only old folks would really know, right? So have you seen that information gap? Is it a perpetual problem because
Yeah.
people are always falling off the cliff and new people are coming in to take their place. How does that land on your doorstep? And what are some of the remedies to maybe better prep people entering this industry, or better memorialize the information before people leave the industry? How do you guys deal with that? I mean, that's right in your wheelhouse right there, right?
Right. But, well, first off, just to put things in that perspective of the aging and everything, and talk about these tin whiskers I have up here. A while back, we were teaching at some big venue. It was either SMTA or Apex. I believe it was Apex, one of our courses. And at one point in time, I'm trying to give an example. Well, HP did this study back in 1985. You guys remember what boards looked like in 1985. My God, the smallest component we had to deal with was 0805, and we didn't have BGAs yet. And Jim says, Phil, most of these people weren't even born in 1985. Whoa, sobering moment. So, yeah, and we've seen these, the various stages, the industry when we first started really outsourcing big time and really big time overseas. And we saw this erosion of the engineers. And for some reason, I guess, Jim and I will tell you, engineering is not considered a glamorous profession these days. I think we're making a little progress. 3 cheers for STEM, for one thing. But yeah, it's a dilemma. I mean, it's a head scratcher. Jim?
And Mike, the obvious question is we look at continually at what other courses we can put together to meet these needs. You see this it being reflected. The SMTA, we've supported that extensively. We teach for them. We've helped develop their process engineering thing. They're expanding that into many other areas. And the IPC on a different track is really getting into trying to fill this gap, but it's a real problem. And, we try to do as much as we can to support it.
Yeah, excellent.
With our own offerings.
Right. Let's talk about the show, Board Talk, and the book that came out of that, electronic troubleshooting electronic assembly, wisdom from the Board Talk crypt. I like the title. Is there well, first of all, what type of questions? Give me just a sampling of the array of different subject matters that you get on your show and then subsequently your book.
It starts right from the beginning with PCB questions about surface finishes and PCB handling coming in as an input to testing and rework and repair and everything in between. It's amazing. People have questions about all aspects. If you're if you think about what we're talking about, the lack of talent. You're a process engineer, quote unquote, and you've had limited experience, and all of a sudden something goes wrong with your in-circuit tester or some other process that you haven't had much time yet to get familiar with. What do? Well, you write a question to Board Talk, or now hopefully go to our book, buy our book and go to it.
Buy the book.
Buy the book. Always a good answer. Buy the book. First recommendation, buy the book. In your more than a decade in producing Board Talk, have you seen a common theme? As I mentioned earlier on this show, voiding keeps coming up. It's like, I don't want to talk about voiding for another hour, but obviously we do, because if it keeps coming up, it's still a relevant subject. Is there a common theme that just won't die, that just keeps coming back to haunt you guys?
Miniaturization and sub-miniaturization and ultra-miniaturization. A process step that you did one way, as Phil said, when your smallest resistor was an 0805, talk about stencil printing, handling, inspecting, all the things that interact with it. All of a sudden now you got an 0201. Oops, tombstoning becomes a big issue. Solder paste deposition, pad design. Now all of a sudden 01005s, you can't even see them in the pocket of the tape, right? We have to design smaller 4mm tapes to handle these things properly. So if you look at a driving factor, it's one of the mantras of electronic assembly is smaller.
Yeah.
Right. And the other thing is also hovering over all this, a common theme, the dark cloud, which has really been there ever since the inception of surface mount technology, is designed for manufacturability.
Oh, yeah.
So all the things that Jim mentioned, they all come into that. And and even more basic things too. But they all kind of hover around that fog, and it's just a lot of questions we get are related directly or indirectly to DFM.
On the subject of miniaturization, I use this kind of a joke to make a point in a lot of my presentations, and I think I've mentioned it on the show. I talk about miniaturization in the context of electrochemical migration issues, ECM issues. Miniaturization is a real issue for ECM prevention, right? Because all of a sudden there's the lack of space between conductors. The reduction of space between conductors is also a reduction of residue tolerance, right? They just go hand in hand. So I show a picture of a QFN, and which is slammed to the board with virtually no gap, under between the board and the bottom of the component, and we have to clean under it, which is really challenging. And I show like a mother scolding her child. And I say, if you don't tell your children you love them enough and give them a thriving, love-filled environment, they will either grow up to be sociopaths and serial killers, or bottom-terminated component designers, and to get back at the world. That's just a commentary on the way our industry works. It's rather peculiar, and perhaps other industries share this frustration, but in our industry, we tend to get new components that come down the line, QFNs, for example, BGAs prior to that. And the industry goes, wow, it's amazing. All this technology packed into this small footprint device. This is great. We can put 1,000 of them on a board. That's wonderful. How do we place them? Oh, I don't know. That's your problem. We just designed the package. You figure out how to mount it. And then the industry has 5 years of trade shows and symposiums and folks like yourself and others that teach how to do it. And then we argue about the best way and how to reduce voiding and how to reduce tombstoning and how to do it.
Time out, Mike.
Yeah.
Somewhere in there were some gurus in laboratories and big manufacturing facilities that physically figured out how to do it often by trial and error with some amount of analysis. And then those people pass on that, either teach it themselves or they pass it on to people like us. And then we can start that cycle. But somewhere along the line, somebody has to do the dirty work.
Exactly.
Usually
but it's
in a development lab or at a big company where they have to deal with this, and they've got their own enough engineering talent in-house that they work it out.
But it's never the people that design the components. It's always the users that have to figure it out in
absolutely.
At 3:00 in the morning in a dark lab, dimly lit lab. It's always done kind of behind the scenes and then slowly rolled out. And that's just an interesting part of our industry. And I'm not quite sure.
There's a mantra we often cite that goes with the evolution of our technology and the products. And that is, make it faster, make it cheaper, pack in more functionality, make it smaller. And so that mantra certainly just defines our technology as electronic assembly and service mount technology, but also understand it's being driven by components that have that exact same mantra: more functionality, make it cheaper, smaller, faster, and that's kind of one of the things driving that very tech. So we're the trickle down.
Let's be real honest, Mike. You've hit on QFNs, bottom terminated components, and all their issues. You go back. When they evolved in putting together information, I started to keep a list of all the positive attributes of bottom terminated components. And everybody had their own list of what was good about them. Tops of the list is they're one of the cheapest packages you can build for an IC.
Right. Well, there's a lot of attributes to them. We just have to figure out how to use them. Right.
Cheaper.
Exactly.
That's a hard one to fight.
Yeah, well, it's not just cheaper. You can put a lot more of them in a smaller space.
Oh, yeah, that too. But
it's nirvana, right?
But I mean, think about it. If it wasn't any smaller, it wasn't any different than another package, but it was cheaper, there'd still be a lot of motivation to use it.
Sure, right. This has motivation coming from all angles. On the Car Talk show, the NPR Car Talk show, there's a segment on there called Stump the Chumps. Have you ever been stumped on your show? Have you ever now obviously your show's not live, so you don't ever have to admit to going, what the hell did they just ask? I have no idea how to answer it. You find the answer. So ultimately, you always find the answer, or just don't publish it.
Do people ever ask us about electric brakes on a trailer? Right. In Car Talk, that was the classic. We know absolutely nothing about this, but we're going to try to make up an answer. They actually did that live during the show. They refer back to it in their things.
Yeah.
And
have you ever been stumped? Has anyone ever asked you, like a legit question, not some crazy, made up question designed to stump you, but have you ever just kind of scratched your head and looked at each other?
I don't think we've ever been completely wrong, but we led people in a direction. Somebody was one I remember was reworking BGAs. He's talking about reworking BGAs and the idea of how do you deal with this? Should we put more paste down to make it more forgiving and so forth? And we theorized, yes, you can do that, but you got to deal with how you're going to put the paste down. You're going to use a mini stencil and put it on the board. You're going to try to print the paste on the balls. And we just talked in very general terms about that. And we said, I think we said on the side, you can also, some people just use flux. Well, one of the best things about Circuit Insight is that they have write-in comments, and they publish them after time. So if we put out a new Board Talk episode, they'll put it on Circuit Insight, and then if comments start to come in 2 weeks or a month later, they'll republish it listing the comments. Well, the comment section on that was everybody who I repair BGAs every day, and the only thing that really works is sticky flux. Forget about paste. We just got like 3 or 4, half a dozen technical things from people who are down there repairing BGAs every day, who said, no, you're misleading. Yeah, sticky flux is the way to go. And many of them gave reasons of why putting paste down wasn't a good idea and all that stuff. So
they're going to fall on their sword over that one, right?
Well, we mentioned it. I think we were general enough to mention it, but we certainly did not give the emphasis that these people felt was important about the subject.
But Jim brings up a very interesting thing. I mean, the Board Talk podcast exists in a very interesting form. The fact that you called up, it's I think it appears twice a week, and some are new and some are recirculated, as I mentioned earlier. But the idea that you click on it and you get the audio, so you can listen to the two guys whose faces were definitely made for radio, and then there's a transcript, and then following the transcript are the comments that came in, and that is really a wonderful tool. In the sense that you're not just getting whatever wisdom we're imparting, but other people's insights too. Now, a lot of cases it's very good, and they'll come up and you guys were way off on this, this and this, or no, I concur with what the brother said, and this and this. So we actually get some interesting debates, and we get other things. Some people write in, that kind of a commercial aspect, pushing their methodology or technique, or you'll get
sneak it in there, right?
Well, IPC 610.3 Section 9 says this, and this. Okay, but but are you really building boards? This is life on the floor. So it's really cool. The other interesting thing we noticed when we meet people that partake of Board Talk, generally if they're under 35, I would say, they said, yeah, I listen to Board Talk. If they're basically over 40, it's I read Board Talk. So just a sign of the times is generation.
Yeah, it's interesting. On this show, on this podcast, Reliability Matters, we have 2 channels. One is on our YouTube channel. So if you're watching this on YouTube right now, you can appreciate the fact that we can see our faces meant for radio, 3 faces meant for radio right here. But if you're listening to it, you're thank God you're missing out on the torturous 3 faces made for radio. But more people. By far, more people subscribe to the audio-only version than the YouTube version, because YouTube version requires that you sit down and basically stop doing other things and watch it. Where the audio version, you could be on your treadmill or in your car or Lord knows wherever. You talk about faces made for radio, and I apologize to our listener-only folks, but just close your eyes and imagine this. You say you have a face made for radio. And this is the back of your book right here, where, most of the time there's a inside sleeve. It shows a picture of the author. In your case, there's these just little pencil caricature drawings of Phil and Jim, and it's really obvious which one's Phil and which one's Jim. So anyway, if you're listening to this and you want to see the caricature version of our guests, just go to the show notes and I'll have a link to that illustration there.
Yeah, if you know any good animators, maybe we'll have come up with an animated version of it.
Yeah, one of them looks surprisingly like Groucho Marx. I don't know. It could be it could be Groucho. So, what's the funniest question you've been asked? Do you have any recollection of that? You've probably been asked many funny questions, or at least filtered through your sense of humor. It's funny.
You'll get this one, Mike. People proposing cleaning methods using glass cleaner, abrasive soaps, and other things that, like, I cringe at thinking about bringing them in the same room with a circuit board, much less putting them on a circuit board to try to clean it or shine them or something. I think, to me, those are the funniest.
I toured a shop once that was a very DIY kind of place, kind of low budget contract manufacturer, and they made their own equipment wherever they could. And they made a washer and a dryer for circuit boards. Rather than buying a cleaning machine, they basically appropriated the dishwasher rather poorly. But back in those days, it was mostly through hole, so it was probably good enough. And then for drying, I thought this was ingenious, all scary, but ingenious. They created this rack in their dryer, and their dryer was, has a spin cycle on it. So they basically created this rack around the edges of the drum where you load boards into it. And you remember the carnival ride you'd stand up against this padded wall and it would spin so fast it would hold you against the wall and the floor would drop out.
Cyclotron, I think.
That's it. Yes, and you'd be just stuck against the wall. Well, that was how they spun dry boards, right? They had a little heat and they had this centrifugal force, and the water would, just come out from under the components and get into the drain somehow.
Another famous one was putting weights on BGA components to hold them down during reflow on the top side.
No tombstoning.
Obviously trying to deal with warpage and splattering of solder paste or something like that. But,
Yeah, but we I guess you say, between things like board talk and more our practical, consulting experiences, the whole range of shops. I like to say we've seen it all, but there again, we haven't. But we've seen people using Windex to clean boards with, so you get any cleaning. Using paper slicers, for the cutters for singulation of boards. We've also seen the old karate
So descoring would be just the old staples.
Yeah, exactly. Yeah. I know I get all my PCB assembly supplies at Walmart and and Staples. Oh yeah. So it's like nothing seems. Hey, some of the stuff actually works, like your centrifugal dryer there. It's like you never know. Where ideas come from. I mean, let's face it. We all remember back in the days, going back to through hole, that what was the original batch cleaner. Like Maytag dishwasher.
Maytag dishwashers, exactly.
And so from that evolved the batch cleaners that we have today.
Sure,
so it's like, you never know with this stuff. Always keep an open mind and a good sense of humor, and don't take things too seriously, right, Jim?
That's good advice, no matter what industry you're in. So let's talk about current times. We have there's two types of events that occur in any industry. There's revolution and evolution, right? We don't see a lot of revolution. Basically, I remember reading an article not too long ago that talked about pretty much every device we have today is just a faster, smaller, cheaper version of something we had in the 60s or 50s, right? Air travel is a great example of that. We haven't sped up an airplane other than Concorde and fighter jets. We haven't sped up an airplane in 60 years. And cell phones have been around since the 60s, and pretty much everything has been around. Internet's rather new, but the internet is just a combination of things that we've always had. We've just managed to connect them together. So we have a lot of evolution in this industry. the electrification of cars is really kind of a back to the future event. It's just history repeating, because the earliest cars that were ever made were all electric. The Ford exploited the internal combustion engine, the ICE engine, for reasons that, we didn't have a good electrical grid back in those days. And he figured that, gasoline engines would be better and more popular than electric engines, which would be very limiting, which he was right at the time. But we've just come back to the original foundation, so this is just cycle of wash, rinse, repeat, and make better. So in this day of electrification of cars and Internet of Things, IoT, which I've long said, frequently said, is IoT is basically putting electronics in things that don't need them, and just because we can, not because we necessarily need to. But we're taking IoT stuff, we're taking electronics, putting them in arguably a lot of class 1 devices, right? That, toothbrushes, for example, that are now connected devices, doorbells that are now connected devices, smart meters that read the water flow for your house or electrical consumption. None of those could be arguably class 3. If they fail, no one dies. However, because they're being built and they're being broadcast into harsh environments, because they go on people, wearables, for example, they go on people go into harsh environments. All of a sudden, they almost have to be built to class 3 standards to work, right? And even if it's an $8 part, it kind of still needs to work, right? Even if its cost of failure is nothing. So I'm seeing, at least from reliability, contamination removal, reliability standpoint, I'm seeing a lot of class 1 stuff now going through hoops that were generally reserved for 3, maybe 2, but certainly 3, class 3. Are you seeing that in other forms of electronic assembly? Are you seeing this proliferation of electronics into areas that had been void of electronics in the past, creating any challenges? Are manufacturers of textiles now having to learn how electronics work? The car industry had to learn very quickly how electronics worked in the last 20, 30 years, particularly in the last few years. Are you seeing this kind of new emergence of standard technology into a new field where there's a lot of missing information? Does that kind of rambling question kind of make sense?
Light bulbs.
Light bulbs,
We spent,
that's right.
5 or 6 years ago, we spent most of our consulting times in light bulb factories teaching them how to build the little circuit boards that are necessary to fire LEDs.
Yeah, that's a good point. And actually, I'm glad you brought up LEDs, because there was a learning curve with LEDs, with the backing material, silver backing material, and then they found out that there's sulfur in the air, which occurs in certain industrialized nations. The LEDs were failing. You're aware of what I'm talking about there. So no one knew it until they built them, right, and put them out in the field. But
you talk about the classic class 1 consumer product.
Exactly.
A light bulb.
Throwaway, right.
But yet it does go in, as you said, Mike, goes into some really harsh environments, and you still want it to work.
Right. So kind of the definition of the classes, class 3, class 2, class 1, I think there's going to be a little bit of recalculation of those, because an $8 or a $4 LED light bulb that's supposed to work for 10 years would put a company out of business if it only worked for 1 year. Yet nobody dies. It's just inconvenient. But they still have to build in a manner that will allow the part to last for its intended life in the intended climactic operating environment, which may very well be a class 3 requirement for solderability, for placement, for contamination, whatever all the class 3 differences are, IPC class 3 differences between 1 and 3. You might have to start applying those. They might have to actually start doing it right and doing it better, just to survive in their intended application, in the intended climactic operating environment. It's kind of, it's a reapplication or an application of different rules to different products that we really haven't seen too much before, right?
Yes. But we've actually run into this kind of questions, and Phil has coined the phrase. Well, actually, I think we picked it up from some customers of a little at the other end, IPC class 2.5, or now I think we're talking 1.5, where people have always had special requirements where you got a class 2 product, but you have some requirements that need higher reliability, so you need to adapt some of the rules of class 3. We've seen that for many years with class 2 products. And now I think what you're talking about is it's just filtering down to class 1. So
Yeah.
you got class 1.5 or something like that, where you as a developer and in concert with your customer, what do you really require? What's required, cost benefit ratio, years of service, and all those good parameters. And then working with us to translate it into some combination of the traditional rigid IPC class 1, 2, 3 things to give your product the service life that it needs at the price it has to be produced at.
Yeah.
We've seen some other interesting things that challenge how things are being judged. We typically think of class 3, either harsh environment, things along those lines, and of course then we have class 3 mission critical, where if it fails, somebody or somebody's are going to die. But to give you an interesting example, there's one customer we were dealing with a number of years ago, and they were building windshield wiper controls, particularly for SUVs. And the windshield wiper control product circuit, if you will, for the front windshield wipers was considered class 3, whereas the one for the rear window on the SUV was class 2. Why? Because if that first one fails, you're going down the Mass Turnpike in middle of God knows what kind of wintry mix, I believe it's what it was called, in the winter, and that fails, and you can't see where you're going. But on the other hand, the rear windshield wiper, not as essential,
right,
especially these days with the cameras. So it's just interesting, the divisions we see that where, and what is actually defined, and sometimes it is blurry, or you want certain aspects of class 3, but you don't want to build the entire thing class 3, and that's kind of where class 2.5 kind of evolved. God, we've confused a lot of people with that over the years.
Yeah, they're actually thinking, Bill said it, Jim said it, and I can't find it, 2.5.
Yeah.
For the auto industry, again, we've talked about this on the show before, the electronics use within the auto industry has gone from infotainment, intermittent windshield wipers, things like that, or maybe with the windshield wiper is an exception, but arguably the electronics in cars that we grew up with, which basically the radio, and if you had a fancy car, the self-retracting antenna, radio antenna. But if they failed, you might be irritated, but you're not going to die. Electronics in cars today are akin to the glass cockpits we see in flight computers we see in commercial aircraft, right? They're now keeping you alive. And again, I've reused this example over and over in the show, so I apologize to my regular listeners for the redundancy here. When I learned to drive a car, back in the 70s, I learned to look over my left shoulder before I changed lanes to the left. I learned to look over my right shoulder before I backed up. There was no cruise control. There was no collision avoidance. There was no adaptive LiDAR, distance monitoring systems or anything like that. So the first time I acquired a car, this is a few years ago, the first time I acquired a car with all of the ADAS systems, all of the safety systems, it was a pretty, as we used to say, loaded car, right? You've been in it, Phil. And it has everything. And the first time I used my adaptive cruise control, that will keep a distance between me, a set distance between me and the car in front, my foot hovered over the brake because I was convinced that I would react faster than it. The first time I started using my blind spot indicators, where you have a little light that flashes in your mirror, and in my car's case, the seat vibrates if it's trying to call your attention to something. I would look at the blind spot indicator and look over my shoulder. Going backwards, I would look in my mirror, turn my head over my shoulder, not rely on the collision avoidance system. I now rely on all of it. My foot no longer hovers over the brake when I'm on cruise control and the traffic's slowing. I no longer look over my shoulder before I make a lane change. I trust my systems. They have never failed. And as a result, I am now, today, probably a worse driver. I'm less skilled because I've let those good habits fall by the wayside and replace them with automation. So if that automation fails, I might hit something, right? And so the automation, the electronics, I should say, in cars, in any vehicle, has transitioned, evolutionized from infotainment and luxury, low cost of failure, to human life, life or death. And suddenly, cars now are really up there at class 3, because they just can't fail, or people can get hurt, or property can get damaged.
That's a good point, Mike. But another thing with automotives is the ever increasing temperature requirements or desirability, because the hotter a piece of electronics can withstand, the closer I can put it to the engine.
Right.
And that has significant advantages in some of these advanced engine control systems. So the difference between a piece of electronics working reliably at 130 degrees C or 140 degrees, a big push I'm reading about now is 150 degrees C. There's apparently some boundary. If you can get a solder joint or the electronics, and typically the solder joints are the weak point, that will live successfully at operating temperature 150 degrees C. This has big advantages for implementation in the automotive environment. So that's another aspect of that's pushing it.
Yeah, we're definitely going closer and closer to the edge of the envelope between miniaturization, in-use climactic environments, the harsh environments we're putting these into, and the expectations of reliability that we have today that we really didn't have on such a wide array of electronic applications. It kind of everything now has to work, and because everything is connected to everything, and even the small thing that didn't, on its own in the abstract didn't have a lot of reliability expectations now connects things that do have reliability expectations. So it's the weakest link issue that we're seeing right now.
But the interesting thing is, Mike, there's a lot of nuances, for lack of a better word, in the assembly infrastructure, to put it that way, that we're seeing they've been around, but they're gaining more and more important. So things like traceability, it's becoming almost mandatory, and that was being, besides a lot of medical and military, that's also being very heavily driven by the automotive. But we're seeing it trickling down into other areas. Another area, of course, is inspection. Has come a long, long way. Jim and I think anybody who knows us, that one of our favorite soapboxes is solder-paste inspection, post-print inspection, and SPI. SPI's come a long way. All AOI is coming a long way, and it's continuing to evolve. Very competitive. It's continuing to evolve. Incorporation of artificial intelligence into this area looks all very promising to again support those reliability expectations that we have, or we're demanding, I guess you could say. So the evolution continues in that respect.
It's almost a cliche, but I think it may be true. Maybe you can myth bust it for me. It's been long said that most reliability issues begin at the printing process. And I don't know if that's a true statement from your vantage point.
Absolutely.
Do you think that's a true statement?
Yes. Yeah. We've seen multiple studies analyzing defects, failures, and they trace them back. And the lowest number I've ever seen is 50% are related to solder deposition. And the highest I've seen is like 90%, depending upon the study, the product they were evaluating, and so forth. But yes.
So SPI, AOI, X-ray, definitely worth their weight in gold, right? In terms of getting it done right the first time.
If it's used properly. And that's one of the other disconnects we see that drives us crazy, is SPI, for example, as I said, is one of our favorite subjects, is not a plug-and-play system, at least not yet. There's a lot of nuances. There's a very steep learning curve on it. And, one of the things that drives us crazy is we'll be doing an audit. Somebody will have a very, very high-end, state-of-the-art SPI system in line. They paid, $250,000 for it, something like that. And we're noticing that every board is passing. Okay, well, it must be right here. Then we notice that the settings are set to the factory default settings.
Yeah.
Whoa, what's going on here? Well, what happened is whoever is operating this system hasn't been properly trained on it. Whoever was originally properly trained and operated has, either gone to another position or left the company or got hit by a bus. And so this other person is basically doing this and they're not trained. I can't begin to tell you how many escapes, lack of a better word, we've seen and stuff being built improperly because there's no control over that. And it's everywhere. So it's not only what you have, it's in the way that you use it. It's heard that used for a lot of things, but yeah.
A past guest on this show, Patrick Stimpert from a contract manufacturer on the East Coast called Matrix Group, I think they're out of Pennsylvania, invested heavily in AOI SPI systems, and together with a manufacturer of those systems, they produced an article, and basically his contention. He's a super lean guy. He's into not just lean. He kind of put his own stamp on lean. He calls it lean in, and he designed his factory floor rather than a linear, left to right, right to left. He designed it as a figure eight, and incoming comes in one end of the building, outgoing goes out of another end of the building. They have parts bins and automation exactly where the parts are needed. He's super, super, super into optimization and efficiency, and he invested a considerable amount of money in AOI, SPI, stuff like that. And his contention, and he has the numbers, he says, to back it up, is that any North American manufacturer can compete with any manufacturer anywhere in the world and be just as competitive if they invest in automation and inspection. That's the difference. It's not labor. Everyone thinks, well, you can build it cheaper over there. Well, yeah, you could. The cost of labor is cheaper, but the cost of inspection is just the same in Shanghai as it is in Sydney, as it is in San Francisco. The machines all cost the same amount of money. And with the right amount of automation, we can be just as competitive as any contract manufacturer overseas, which is interesting. And his big thing is escapes. No escapes. Find it, fail fast, fail at the factory, and, just don't let it get out. And they even publish an electronic board that shows the number of defects they've had. And when customers come in, it's up. And the people who are responsible for running that department, their success or their failure is right there on the screen. It can't make it go away. And there's just a lot of emphasis on getting it right the first time before things go out the door. And
well, I think he's definitely on the right track. Yeah, but I would augment that to say, kind of along the lines I was saying before, that you have great equipment, but we still have the people factor, and so training of people, adequate training, and we see this all the time. And let's face it, and since we do in-house training and things like that, it's one of the areas that a lot of manufacturers get skippy on. So when you train your people properly, you're empowering them. There's buy-in, and you can't put a price on that. So automation is good, but with all due respect, we don't have lights out yet.
No, I think we're far away from lights out.
Yeah. So in the meantime, we're still dependent on humans, and we still, again, training them, having them buy in, empower them, take good care of them. Your machines are only as good as the people running them.
No, I totally agree. I'm glad you brought that up. And that's where you guys, or companies like ITM come in, because you don't train machines, you train people. And those people then operate the machines. Let's talk about training just as we wrap up. We're running out of time. There's two ways to get training from you fellas. One of them is the traditional way, hire them. They come into your facility and do their magic. The other way, if that doesn't work out, is there's a few virtual options for it as well. We have a few courses available online. The 10 Commandments of SMT Assembly. That course is worth the money just to watch the intro, because you actually see Phil dressed up as a priest with church music playing in the background. Again, not taking himself too seriously. A little bit of that quirky humor there. But there's the 7 deadly sins of SMT Assembly.
There are 10, Mike.
Oh, there are 10 deadly sins.
Yeah,
there we go.
I
don't even think
the
it said
Bible only has
7
7, but we're so bad we got 10.
Right.
And if you buy now, we'll throw in an extra sin at no extra charge. Right. Operators are standing by.
On the Ginsu knife and pocket fisherman.
Exactly. But anyway, if you want to find out more information on virtual Phil and Jim, you can check out reliabilitytv.com. Then there's also a 4.5-hour course available, which is a best practices for SMT assembly. If you really want to spend 4.5 hours with Phil and Jim and dive deep into all sorts of aspects of surface mount assembly, that is also an available course. Look at the show notes. If you're listening to this podcast on your podcast app, look at the show notes. I'll provide links to those courses if you're interested. And if you're watching this on YouTube, just look down, click the show more button, and you can get links to those, to more information about those courses. Gentlemen, Phil, Zarrow, Jim Hall, thanks so much for agreeing to come back. It's been just over an hour of very interesting and enjoyable conversation, entertaining conversation. I appreciate the unique perspective you bring to this industry. We need it in this industry that could be otherwise a little bit dry. And thanks for your expertise and making it a little bit more palatable to swallow. I appreciate that.
Mike,
well, we appreciate being here, Mike, and for you and everybody who happens to watch this. No matter what class you're building, 1.5, 2.5, 2 3/4, don't solder like my brother.
And don't solder like my brother, please.
I was hoping you would end that way. We didn't rehearse this, but thank you. You made my day. Don't solder like those guys, but take their advice. Just don't watch them. Just don't watch them solder. Just listen. All right, fellas, thank you so much. It's great to see you. I look forward to seeing you in person again. I'm sure, if not before, I'll probably see you soon, at SMTAI or in Minneapolis in the fall, right?
Yeah.
Hopefully
right.
so.
All right, fellas. Sooner.
Take care.
Thanks, Mike. Thanks for your contribution too, man. Thank you.
Hey, my pleasure. Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks for your questions and episode suggestions. Please keep them coming. Send questions or comments to Mike at mikeconrad.com. That's Conrad with a K. And once again, thanks for listening or watching. If you're watching this on YouTube, be sure and click the subscribe and the bell icons to be notified when new episodes are released. I'll see you again in a couple of weeks. In the meantime, stay safe, stay healthy, stay happy, and of course, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.